The logic of hypothesis testing. Our objective? Let's explain the logic of hypothesis testing. Basically, before we start doing some hypothesis testing, and we're going to do it both with population proportions and population means, let's talk about the logic behind it. Okay, let's first define statistically significant. The result observed in a sample is unlikely or unusual when the null hypothesis is assumed to be true. Okay, that's what statistically significant means. It means that the result we see is unusual when the hypothesis the null hypothesis is assumed to be true. When observed results are unlikely or unusual under the assumption that the null is true, we say the result is significantly significant, statistically significant, and we reject the null hypothesis. So, in a nutshell, here it is right here. When something is unusual, okay, when it's unusual, it is statistically significant. When it's unusual, we're going to reject the null hypothesis. Okay, our data suggests that what happened here is unusual. Therefore, what we thought was true, we're going to reject. Okay, statistically significant, unusual, we reject the null hypothesis. There are three methods for testing hypotheses: the classical approach, the p-value approach, and the confidence interval approach. Let's take a look at them. The classical approach. We've worked with this. The classical approach uses the normal curve and whether or not the sample proportion is beyond 2 standard deviations above or below the mean. Okay, what does unusual mean in this case? In the far tails of the normal curve, the 5%, 2.5% for each tail that is outside of the 2 standard deviations. So let's just remind ourselves what this looks like. Here is an okay drawing of the normal curve. There's your mean or your average. We go out positive 2 standard deviations, and we go out this way to minus 2 standard deviations, and we say we know that according to the empirical rule, okay, this between these two represents 95% of our data. Well, unusual is the other 5%. So here is the high 2.5%. This is the low 2.5%. If your data is in this tail or in this tail, in that 5%, it is unusual. It is outside of the 2 standard deviations. Okay? If the sample statistic is too many standard deviations from the population parameter stated, okay, too many standard deviations is beyond +2, beyond -2, it is unusual, and we therefore reject the statement in the null hypothesis. Back up here, if it's unusual, we reject the null hypothesis. We're not going to spend much time with the classical approach because we're going to be using technology, but this is something that draws from what we've already worked with. Okay, the p-value approach, which we're going to work with, is a second approach for testing hypotheses. Okay, it uses the calculated, of course we're going to do this with StatCrunch, p-value. So what is the p-value? The p-value is the probability of observing a sample statistic that is as extreme or more extreme than the one observed under the assumption that the statement in the null hypothesis is true. In other words, the p-value is the likelihood or probability that a sample will result in a statistic such as the one obtained if the statement, in the null hypothesis is true. Lots of words can be kind of complicated. It will take some practice to get used to this. What does unusual mean in the p-value approach? What it means is the p-value is less than the level of significance, which is alpha. We've discussed that before. Okay, we're going to be given a level of significance. If the p-value is less than that level of significance, it is unusual. Okay, and here's a cute little statement. If the p-value is low, the null must go. Okay, unusual, the null has to go. Unusual is when the p-value is low. It's below the level of significance. So if the p-value is low, the null must go. Okay, if the probability of getting a sample statistic as extreme or more extreme than the one obtained is small, under the assumption the statement in the null hypothesis is true, it's unusual, and we therefore reject the statement in the null hypothesis. Again, if it's found to be unusual, we reject the null hypothesis. Our last method for testing hypotheses is the confidence interval approach. Okay, and we're going to use the calculated confidence interval. We're going to use StatCrunch for that. And we're only going to worry about this approach or use this approach when we're dealing with a two-tailed test. Okay, two-sided test or two-tailed test. And unusual means it's outside of the confidence interval. So whatever interval you come up with, you have a lower number, and an upper number. If you're outside of that, it's unusual. Okay, so if the sample statistic is outside of the confidence interval, it is therefore unusual, and we therefore reject the statement in the null hypothesis. So key things here. Okay, if it's unusual as defined by that test, we are going to reject the null hypothesis. Okay, statistically significant means it's unusual. If it's unusual, we reject the null hypothesis.